Hello, in this video we're going to be investigating the big integer and big decimal classes. So what this video is about is investigating how we can represent and manipulate numbers of arbitrary size and precision. So what do I mean by that? Let's jump over to Eclipse and we'll do some testing. Let's create a new Java project called big number. That'll be fine for now. And I'll add a new class and we'll call this big number test. And we'll add a main method. Exactly how big are we talking with these numbers? I mean, the primitive data types in Java can store some pretty big numbers. Let's find out exactly how big. So, a long int, for example, so the biggest value that a long data type can store is this. See, that's a reasonably big number, but sometimes, particularly if you're doing scientific computing, you'll need to store really big numbers, bigger than this. And if we need to do that, we're going to run into problems if we're trying to use primitive data types. For example, what happens if we try and do a multiplication operation on our long number here? So let's multiply it by 2, for example. When we do this, we get minus 2. And the reason for that is because we're storing the biggest number possible inside a long. So when we multiply it by 2, the bits representing this number, remember a long is 64 bits, are wrapping around back to 0. So we end up with -2, which is not at all what we want. We can multiply this by anything. And we're clearly not going to get the right answer. So, how do we fix this? There are two classes that we're interested in this video, big integer and big decimal. The big integer class works just like an integer, an int or a long. However, it can store a number of any size. It doesn't matter how big it is. It just keeps using more memory as it needs to represent the number. And a big decimal is kind of like a floating point number, except in that it can store information after the decimal place, but it's not floating point at all. It can store a number of arbitrary size and arbitrary precision. So we can have numbers going off after the decimal place forever if we wanted. So let's have a look at how we use them. Let's leave that for now. Let's create a big integer object. It's just like any other object, so we have a few constructors. So you can see here, the constructors take in a byte array, a string, or some other things as well. So a sign and a magnitude, so that's scientific notation, and all this kind of thing. So you can note that none of these constructors actually take a number all by itself, but that's okay, because what we want to do is, let me just comment this out for now so we can run our program again. We're going to use the constructor that takes in a string, and I'll copy this and paste it into the constructor. So there you go. Here's our big integer. So how would we go about multiplying that by 2 like we did before with the long, which didn't work? Well, it's pretty easy. We're just going to create two big integer objects. So we'll call this one b, and we'll give this one the value of 2. So we can print these out. This works because big integer and big decimal both implement the toString method, so we can go A concatenated with that. So what we're trying to do is this, which is what we tried to do before and it just didn't work. So let's try it now. So the way we do this is the big integer class has a method called multiply. So a dot multiply b. Let's move this up here so we can put it as part of our print line statement. So a multiplied by b equals c is what we're going to print out, and we get this huge number which just off the top of my head does look like it's double that number. I'm not going to really check it, but that sounds like it's working correctly, and there's no reason it shouldn't. So the point is, if we want to store big integers, we can use this, and we have unlimited size available to us, which is very important for some types of programs. So how do we go about manipulating these? Well, if we have a look in the Java API documentation, you'll see that the methods have all the regular mathematical methods and functions and operators that we would expect. So we have an absolute value. So basically all the methods that are in math, the math class, they will be in here. So we have abs, we have add for doing addition, we have divide, we have equals for comparison, and all things like this. So maximum and minimum, modulus, negate, multiply. So that really is how we do it. All these work in a similar way to how the multiply method worked. So that's pretty good. Big integer, very useful, and not very difficult to use. But what if we want to have a decimal place? Well, we can do that. That's fine. We, instead of using the big integer class, we'd use the big decimal. And it works in a similar way. And let's pass in 1.0. There is one thing that we need to be careful about when we are using decimal numbers, and that is divisions where we would normally get a recurring decimal place. So let's try this out and see how it works. So big decimal hopefully you can see where I'm going to go with this. If we do 1 divided by 3, we're going to get a recurring decimal of 0.33333 recurring. But what's going to happen here? Well, it's a bit tricky because remember I said big decimal can store arbitrary precision. So we need to have a look and see what happens. So actually let's just do this. D dot divide E. So we're doing 1 divided by 3. Let's run this. Uh-oh, our program has crashed with an exception. It's arithmetic expression. Non-terminating decimal expansion. No exact representable decimal result. What that's telling us is the operation we've tried to do can never be absolutely computed because there's no exact result. The recurring decimal place goes on literally forever. So we need to be careful of that. We either need to catch the exception or do something a little bit different. What we can do in our divide method, there's actually another version of this, a few different versions of this. So we have a rounding mode or a scale and the rounding mode, which is the one we're going to look at. The scale is essentially the number of digits after the decimal place. So let's put in 20. The rounding mode is how it's going to round. So big decimal dot. So we can do ceiling, down, floor, half down, half even, half up, unnecessary, or round up. Let's do round up. And now when we run this, you'll see, oh, I forgot to print it. Now you'll see that the division works and we're going to 20 decimal places and then we're rounding, which is exactly what we'd expect. And we can literally go to anything here. So let's 100 decimal places. Wow, look at that go. And it works just fine. There's no way we could do that with one of the floating point data types like float or double. It's just not possible. So, and the rest of the methods in big decimal work in a very similar way to the ones in big integer. And the reason for that is because they both extend from the class number. Okay? So this is an abstract class that defines some of the values, some of the methods that we need to have, and you'll see here that we've got all of these. Oh, they're there. There they are. Sorry, I have to scroll down a fair way. So divides, equals, all these things exist in these classes. So we can use them almost like they're primitive data types, but they're not. Of course, they're objects. So with that, that's it for this video. So just quickly to summarize again, big integer can store an integer of any size. A big decimal can store a real number of arbitrary size and precision. And the classes provide methods for manipulating these numbers, similar to the arithmetic operators available for primitive types and the methods that are available in the class math. So with that, that's it for this video. Thanks a lot.